Welcome. In this video I'm going to show you how you can obtain effect sizes after a post-hoc test for a goodness of fit analysis using R and Jupyter Lab, but the R code should also work in RStudio and my stikpetR library. The R version that I'm actually using is 4.3, but it should also work in other versions. Now this is to focus on after post-hoc tests for goodness of fit. Depending on which test you've used, you can use a different effect size. So for example, if you used a binary test, so for example binomial or a z-score or z or score test or a wall test, then you could use Cohen's G, Cohen's H2 or the alternative ratio. If you use the chi-square test or something similar, then Kramer's V, Cohen's W, Johnston, Berry, Mika E, or Fay should be possible. And if you used a test that calculates a Z value, then you could also use the Rosenthal correlation coefficient. I've actually separate videos on each of these in case you just performed a regular test on it. But in this video I'll be showing you how you could actually obtain after post-hoc test for all of them in one go. To show you this, I'll need some example data, so I'll be using the General Social Survey from 2012, adjusted for some example purposes. After it's loaded in, I actually don't need all of its data, I just need one nominal field. So as a nominal field, I'll be using the MAR1, which is actually the marital status. And to give you a quick overview, I'll convert those into a table. And that actually should then give you the how often each of the values was actually used. It seems like it's running a little bit slow. That sometimes happens. So what I'm going to do is I'm just going to restart all of these, shut down all of them. And now if I load it, it should go a little bit faster, hopefully. Alright, so that was that one. Loading the file always takes a little while. And now hopefully this goes faster as before. Yes, and there we go. 79 people indicated to be separated. Now my library can be installed by using DevTools and then install from my GitHub. It's not available on CRAN, so you can't just do install packages. But once you've installed it, you can actually import it just as any other library. The function of interest is actually ES effect size post-hoc goodness-of-fit. It requires as input the post-hoc results from one of my other functions in that stikpetP library. You can specify which effect size you want to use, and if you've used a Kramer's V, you can opt to have Bergsma correction. Alright, let's have a look. I need some post-hoc results, so I'm going to be using a pairwise binary test on my nominal field, and in this case, as you can see, I've done a one sample binomial with equal distance method. I have a separate video where I go over interpretation of these results, but now I just actually needed it to feed it into that effect size one, and as you can see, it now nicely for every possible combination, it also added the effect size measure of Cohen H. Perhaps you want some rule of thumb to interpret these. I have separate videos on, again, each measure by itself, but we can actually use TH post-hoc goodness-of-fit. It requires the input from the output from before, so of this one. And then if you want, you can convert it to another measure in some cases. And some of them, like JBME and Fay, they will need the post-hoc results themselves. And if you want, you can use the quarks, which in this case is actually the qual, for which rule of thumb to be used. So for example, if I use the post-hoc results and I convert it, and I do convert it, I get the following. I get actually category 1 and 2, the Cohen H value. This is actually a conversion. This is actually Cohen H2 or Cohen H apostrophe, which could be transformed to a regular Cohen H, and then the qualification of that one with the source for that qualification. Just to show you another example, so another post-hoc test, but now using residuals, and a Pearson chi-square test. Then I feed that into the one for the effect sizes, and I specify in this case that I want to have that JBME. So that's this result, and then I can use a rule of thumb again, and in this case see that, for example, for married it was quite a large effect size, but for never married and divorced it was negligible. Right, I hope this video was helpful, and thank you for watching.